For this assignment, we used the graphics library introduced in class, SFML. We had decided on a game design that would allow for as much play as possible with as little manual work as possible, so we knew procedural generation was a must-have. Due to the time constraints and having never worked with SFML before, we decided on a simple automatic running game, similar to the Google Chrome Dinosaur Runner. To differentiate our project from its inspiration, we added gaps in the ground, as well as variable heights. As a bonus, you can even play the game with internet. We chose the main character to be Shroomie, the MC of another game currently under development by one of our programmers, marking the IP's first spin-off. We titled this game Shroomie's Run. Diving into the code, we created a base class, obstacle.hpp, which acts both as the ground /dirt you see the player running on, as well as the base class for pretty much every other object other than the player, including the bushes, trees, clouds, and even the text. To keep track of all the obstacles on screen, they are kept in a vector of type obstacles. Yes, even the hurdle, cloud, and grass classes are la polymorphism. These classes have a simple virtual update function, which handles setting the speed and moving across the screen, as well as getters and setters for speed, position, size, etc. Moving on to the logic behind the spawning of the obstacles, we created a spawner class to do all the heavy lifting. Every time the spawner is about to load new objects, it checks if any objects in its vector are off-screen, via their X position, and removes them from the vector. This automatically deletes them because they go out of scope, so memory usage does not increase over time. Our seasoned statisticians spent hours determining the best values to use for the optimal mix of difficulty and fun when designing the spawner. The spawner uses a random number generator from the C standard library to determine things such as which obstacle to spawn next, when to increase/decrease the ground height, and where to place the clouds. The spawner also has a separate function to create the starting platform, so the player starts on flat ground without any obstacles. On to the object that makes our game a game rather than a movie. Let's explain the player, a surprisingly simple class. Even a toddler would be able to understand it. Similar to the obstacles, the player object checks every frame if the player is falling, pressing a button, touching the ground, and others to determine the action needed to be taken. A timer was added to allow the player to jump higher if the space bar is held, but will not rise indefinitely. Our brilliant programmers have simulated realistic physics by gradually applying an increasing force in the up or down direction to mimic the acceleration of gravity. This results in a parabolic-like movement, where the player peaks slowly, and then begins falling, increasing in speed. The last thing to check for when not jumping is to establish a terminal velocity. We found during testing that the player clips through the grass, resulting in a player death if they fell too fast. Another aspect that sets the player apart is its animation, the only one of its kind in this project. Our amazing animators spent hours drawing and fine-tuning the running animation, as well as creating an animation class to determine the independent frame rate and state of the animation. Thank you for watching this quick overview of the development of Shroomie's Run. Please like and subscribe as it helps the channel out immensely. Only 2000% of viewers are subscribed, and getting those numbers up would be amazing. Have a great day.